All right, good morning. Today we are going to talk about when we have two lines that are crossed by a transversal. Okay, so in this case, like line J, line K, these are two lines crossed by a transversal here, T. Okay, we have several different types of angle relationships. And you can see I have given one example. We need to list the others like it. So this first example, corresponding angles. Okay, so maybe don't mark these, but we're going to write on our list. So angle 1 here, and angle 5. Now, when we think of the word corresponding, like if I have a right shoe, the corresponding shoe to it would be from the same pair of the left version. Okay, so if we look up here, angle 1 is up to the left, angle 5 up to the left. So from the point of intersection, it goes up left, up left. So likewise, if I go up right, that's 2. 2 would match up right with 6. Okay, so angle 2 and angle 6 are corresponding. Now, what if I go instead down to the right? So that's 3. Down to the right from the intersection is 7. So angle 3 and angle 7. And down to the left is 4. Down to the left is 8. So 4 and 8. And those are our sets of corresponding angles. All right. So now on to the next one. Next one, alternate interior angles. Now, interior means inside. So if we look here in between these two lines, the interior 3, 4, 5, 6, those are the possibilities for interior. Okay, alternate means on opposite sides, so like 4 and 6, 3 and 5. I already have 3 and 5, so I'll add angle 4 and angle 6. Okay, our next one, consecutive interior angles. Another word for consecutive is same side. Think of consecutive like consecutive days, 1, 2, 3, one after the other, right? Consecutive numbers, 1, 2, 3, 4, 5, 6, whatever. So consecutive interior angles. Now, we're not talking about these numbers being consecutive. These numbers are just angle labels. But 3 and 6 are consecutive because they're on the same side here, on the right side, and they're on the interior. 4 and 5 would be another example. Okay? They are also consecutive interior. Our next one, alternate exterior. That's on the outside, and they are on separate sides. So, for example, the example given is 1 and 7. Alternate sides of the transversal, one on the left, one on the right. And let me pause this for a second. All right, so as we look at the next one, then alternate exterior angles. So exterior we know is like on the outside. So exterior, outside those lines. Alternate means one on each side. So like 1 and 7, 2 and 8 would be the other example. Okay, then consecutive exterior, once again, that's like same side, but instead of on the inside, it's on the outside. So exterior, outside. So same side of the transversal, so like 1 and 8 here, both on the left. Also 2 and 7, both on the right. Now these last two, vertical angles, linear pair, we've had these before. So vertical angles, 6 and 8. Hopefully you remember vertical angles are congruent, so they're the same. Another example, 5 and 7, 2 and 4, 1 and 3. And finally, our linear pair. If we look here, 1 and 2 is an example. 1 and 2, notice they're adjacent. They are going to be supplementary. They add up to 180. Okay, so 1 and 2 works. 2, 3, 3, 4, 1 and 4, 5, 8, 5, 6, 6, 7, 7, 8. There are lots of different linear pairs. And as we said, we know they add up to 180. And so if you want to have them all listed, I will list them right here. If you aren't as concerned with that, as long as you know what a linear pair is, that is fine. All right, so when we have these, we need to then think about, in this sense, we just are working on naming the angles. But sometimes we will have parallel lines. So if there are parallel lines, some rules come into effect. So M and N are parallel here. They run beside each other, never touching. Okay, if that is the case, then several rules come into effect. So the corresponding angles postulate. Basically, if these two lines are parallel and cut by a transversal, then the corresponding angles we get are going to be congruent. So 1 and 5 are congruent. Another example, 2 and 6, they're congruent. They're the same. Alternate interior angles. If two lines cut by transversal, they're parallel. The alternate interior angles are also congruent. So 4 and 6, congruent. 3 and 5, congruent. Now, the consecutive interior angles, these like 3 and 6 or 4 and 5, they are not congruent. If the two lines are parallel, they will be supplementary. Supplementary, we know, means add up to 180. Now next, alternate exterior. Oops, it looks like I forgot to erase. So give me 1 second. All right, so thanks for your patience. My bad. So if we look then, we said alternate exterior, they're going to be congruent as well. So if we look here, like 1 and 7, 2 and 8. Then consecutive exterior, it's like the same side exterior, so they will be supplementary. So 1 and 8 would add up to 180, 2 and 7 would add up to 180. All right, so we look down here. The first thing we want to do is establish what is the angle relationship. So if these two lines are parallel, which we see the mark, we know, and you can probably guess that they're parallel by how it looks. So now, if we think about this, this is down to the right, down to the right. Those are going to be corresponding. Okay, so at this point now, we have 120 and 5x plus 40. Those are corresponding, down to the right, down to the right. So we are going to just do 120 equals 5x plus 40, because remember, corresponding angles are congruent. We subtract 40, we're left with 80 equals 5x. Divide by 5, x will equal 16. All right, on to the next one. Number 2 here. First thing we want to do is decide what the angle relationship is. Notice they're on the outsides, they're exterior. They're also on separate sides of the transversal, so alternate exterior. I'm going to abbreviate that ALT, EXT. And we know alternate exterior angles are congruent or equal. We add the 10 over, 5x equals 55, x will equal 11. On to the next one. Here, example 3. As you can see, they are on the same side, also known as consecutive interior. Whenever you have consecutive interior angles, we know they will be supplementary. They will add up to 180. All right, so we combine our like terms. 4x minus 1 plus 3x minus 8 equals 180. Combine our like terms, we get 7x minus 9 equals 180. 7x will equal 189 because we had the 9 over. Divide by 7, x will equal 27. And we're done. And we look at the next one. This one, as you can see, down to the right, down to the right. These are corresponding angles. And if you don't remember, corresponding angles are congruent. They are the same. So 7x minus 11 equals 3x plus 41. So we get 4x to equal 52. And x will equal 13. Now number 5 might give some of you trouble. There is actually no relationship between the 114 and the 9x plus 3. We have no relationship. There's not consecutive. They're not alternate interior. But 114 and this angle right here and here, those are corresponding, which means the blue dots have to be the same. So this is also 114. At this point now, if I put a red dot here and here, those red dots are a linear pair. They will add up to 180. We subtract that, we have 9x, then will equal 63. Divide by 9, x equals 7. And we're done. Our final one, we look here, these two alternate sides of the transversal, and they're on the inside, so alternate interior, which means they will be equal to each other. Subtract the x, divide by 3, x equals 21. And we are done. So hope you guys had a good day. Go ahead or hope you have a good day. Sign into Delta Math, try to get the work done for this, and let me know if you need help.